The last topic in Unit 1 is being able to handle density in dimensional analysis problems. So, here is my piece of advice. And it's more like you have to do it. Never start with your density number. It'll be given to you because density is a known physical property for every substance in the world, but it is only going to be your conversion factor. There's going to be another number given to you in the problem, and that's the number you're going to start with. So let me show you. If we have 9.2 grams of silver, how many liters is this equal to if the density is 10.49 grams per milliliter? So you'll start to see the problem's going to be, how do I know what number to start with in some of these problems? But again, for density problems, you're going to start with anything but the density. So I'm going to start with 9.2 grams. I want to get to liters, which is a volume. Density allows me to convert between mass to volume. Now, how do I use it? It's the same idea we've been doing all along, canceling out your units. If grams is on the top, grams has to go on the bottom, right? Now, the density is in grams per milliliter, so I have to put milliliters on top. So you can convert grams to milliliter if you have a density. So it says there are 10.49 grams per 1 milliliter. So that has to go next to grams because it's written next to grams. So my grams cancels out, and now I have milliliters on top. Great, that's a volume, right? Problem is they didn't want milliliters, they wanted liters. So you do one more step. Milliliters goes on the bottom, liters goes on top. Liters is bigger, mill is worth 1,000, cancel it out, done. So you would do 9.2 divided by 10.49 divided by 1,000. And you get 8.7702 times 10 to the negative fourth. Even that, though, is too many sig figs, right? This is only 2 sig figs, so we're going to cut this down to 2 and make it 8.8 times 10 to the negative fourth liters. Now you're done. All right, next one. How many grams are in 4.5 liters of helium? Oops. That has a density of that. All right, so this one might be simple. How do I know that? Because I'm going to start with this, and my density already has liters in it. So this one's probably going to be pretty easy. Will you have ones this easy on your quiz? No, probably not. But I want to show you these basics, so let's start with 4.5 liters. Again, I'm not starting with density. That is my conversion factor. Liters has to go on the bottom. They want grams. Okay, now the grams is going to go on the top this time. Cancel that out. It says there's 0.178 grams in 1 liter. Done. That's all there was to this one. So if I multiply those two numbers, I get 0.801. Now, that's actually too many sig figs, right? 4.5 is 2 sig figs. So you'd actually write 0.80 grams. Now you're done. All right. One more. This one might be a little bit harder. More steps. Again, I see a density, but I'm not going to start with that. I'm going to start with the volume. So I'm going to start with 0.550 liters. Now, liters has to go on the bottom. I have to cancel it out. But my density has centimeters cubed in it. So I'm going to have to go to milliliters first, and then go milliliters to centimeters cubed, so that I can use my density. Hopefully that makes sense. 1 liter has 1,000 milliliters. Cancel that out. 1 milliliter, 1 centimeter cubed. Cancel that out. Now, on the next step, I can use my density. Centimeters cubed goes on the bottom. My density has grams in it. It says there's 8.94 in 1 centimeter cubed. That cancels out. Great. Problem is, they wanted kilograms. So we're going to do one more step. Grams, kilograms. Because it's a base unit, we can do that, right? Kilo is bigger. It's worth 1,000. Cancel that out. So you can see where I do 0.550 times 1,000 times 8.94. But we're dividing by 1,000. So again, you can take a shortcut because you have 1,000 here and 1,000 here. Technically, they're canceling out. So you really could just do 0.55 times 8.94. You should get the exact same answer, which is 4.917. Again, way too many sig figs. This is only 3 sig figs, so we chop this down to 4.92 kilograms. And that's it. Okay, so that's all there is to density ones. Hopefully that makes sense. Again, there's more to practice in your packet. Please do some so you have a good handle on it, and let me know if there's an issue.